Okay, I'm going to tell you a little bit about the 30, 60, 90 special right triangles that you worked on on this worksheet. So if you finished this worksheet, you probably noticed that there was a pattern in the relationship between A, B, and C on every single triangle. And what we're going to do is we're going to use that pattern to help us solve for missing sides. So like we talked about in class, the reason they're called special right triangles is because the pattern between these side lengths will always remain the same. And this allows us to solve quickly for missing sides and to solve for missing sides if we only have one side length. So one relationship you might have noticed was that A was always half of C. Or another way of thinking about it is that C is 2 times A. So if A, the smallest side across from the 30-degree angle, is X, then C, the longest side across from the 90-degree angle, is going to be 2X because it is twice as big. So if I wanted to go from the bottom to the hypotenuse, or from the shortest side to the hypotenuse, I would need to multiply whatever I have at the bottom by 2. If I want to go in the other direction, I'm going to do the opposite operation and divide by 2. And then the pattern you probably noticed between A and B, for example, is that you always take A and multiply it by radical 3 to get B. So A right here was 1, so A times radical 3, A times radical 3, A times radical 3, A times radical 3, and so on. That continues. So this, the back side right here, B across from the 60-degree angle, is always X, the shortest side, times radical 3. So if I wanted to go from the short side to this side, I would multiply by radical 3. If I wanted to go in the opposite direction, again, I would just do the opposite operation and divide by radical 3. And this is where knowing the operations with radicals is going to be helpful to you. So for example, in this first problem right here, I have 14 as my hypotenuse, Z as my bottom side, and W as the mid-length side across from the 60-degree angle. So I know that to go from 14, the hypotenuse, to the shortest side down here at the bottom, I look at my arrows and I'm going to divide by 2. So 14 over 2 is equal to 7. So in this case, Z should equal 7. Then I know to go from the shortest side across from the 30-degree angle to this side across from the 60-degree angle, because now I need to find W, I'm going to multiply the bottom by radical 3. So I'm going to do 7, because that's my bottom side, times radical 3. And because this is not a radical, you can't multiply them together. You wouldn't get radical 21. You just end up with 7 times radical 3, and that's the most simplified form. So W in this case equals 7 times radical 3. Sometimes they get a little bit more complicated, so you have to be careful. You can't just assume that this is the shortest side because it's on the bottom of this triangle. You have to look at how the triangle is oriented. So I know because 30 is the smallest angle that the side across from it will always be the smallest side, and that the hypotenuse across from the 90-degree angle will always be the longest side. So sometimes you could turn your paper to the side to help you think about it, or you can turn this to the side to help you think about it. So if I look at this triangle, I have the side across from the 60-degree angle. And if I look up at my picture, I know to go from that side to the base, I need to divide by radical 3. So I'm going to take 12 and divide it by radical 3. And this is where we do not allow radicals in the bottom. So you need to multiply by radical 3 over radical 3 to cancel that out. So I end up with 12 times the radical of 3 on top, and the radical of 9 on the bottom, which is going to turn into 3. So 12 times radical 3 on top over 3 on the bottom. And then I can simplify the numbers in front, the coefficient of the radical and the denominator of the fraction. We can reduce that fraction. So I end up with this being equal to 4 radical 3. So in this case, x, the base, I divided by radical 3 to get to the base. So this is equal to x. And then for my last side, I look up here for how to get to the 30 degree, the side across from the 30 degree angle to the longest side, and I know I need to multiply by 2. So I'm going to take my answer for x, 4 radical 3, and multiply it by 2. And this is 4 times the radical of 3, and this is multiplying it by 2, so I'm going to end up with 8 times the radical of 3, which is y.